and you have a test on what day?
Tuesday.
Tuesday, test on Tuesday, okay? So I got your study guide. Let's do the last lesson. We're going to pick up with the intermediate value theorem, and my good friend Miss Taylor, or Miss Jordan, say hi, Jordan, everybody.
Hi, Jordan.
Jordan was not here yesterday, so we are going to make sure that she can see this piece as well. Let's pick off with example 2. It says verify that the intermediate value theorem guarantees that there is a 0 on this interval, okay? -1 to 2. What does it mean to have a 0? What does that mean? Yeah, it means that if you plug in a number C, you get 0. That's what we want to try to determine. So how can we guarantee that this does cross over 0? Somewhere between -1 and 2. What will we do? Yeah, plug in -1. So f of -1 is, and we take -1 to the 4th, you get? 1 minus 1 plus 1 is 1. Lots of 1s in that problem, huh? And then we do f of 2 is equal to 32 minus 4 plus 1, and that's equal to?
Isn't it
16?
No, 32, dude.
16 minus 4 plus 1 is 13. So does the function have to cross over 0?
No.
No. So Jordan, if this was not a 1 but it was -1, then we would say to go from -1 to 13, you have to cross over 0. But since it was +1, you don't have to cross over 0 if you're going from 1 to 13, do you? No, you don't have to. So here, the IVT does not apply. Okay? Because we don't have a value that's above and below. If we could find one, then we could invoke the intermediate value theorem. Flip it over. Okay? Now, this doesn't involve, we're just going to do one example here. This does not involve a 0. It says that at some point, the function has an output of 6. It says verify the IVT applies the indicated value of C, then find C guaranteed by the theorem. Okay, so this is just the extension. It's not much to it, but we're going to do the basics of it. Okay, first we're going to find out what f of -1 is and what f of 3 is. So this is what I would be able to expect you to do for your test, be able to check the endpoints. As I plug in -1, I get 1 minus 4 is -3 plus 1 is -2. Are we okay with that?
Yes.
And if we plug in 3, we get 9 plus 12 is 21 plus 1 is 22. Good with that?
Yes.
So that means that, and this is the big idea, that is 6 between those two.
Yes.
Yes. So 6 is between -2 and 22. So the intermediate value theorem guarantees that there's a value C that sits between -1 and 3 that satisfies that. We want to find it. Not too tough. We just take x squared plus 4x plus 1, and we set it equal to what? 6. What do you think I do? Say with confidence. Subtract the 6, and I get -5. Factor, I have x plus 5, and I have x minus 1. So I have x is equal to -5 and +1. I want you to look at your solutions, have a conversation with the person next to you. Is the answer both of them, one of them, or neither of them? Talk, decide, go.
I don't know, because none of them are the same.
5, 4, 3, 2, 1. Anybody confident? Yeah.
It's 1 because -5 is not within the spectrum.
It's 1 because it fits within the interval of -1 to 3. -5 is not within the interval of -1 to 3. This guarantees, the IVT guarantees that you're going to come up with a solution that sits in that interval. That's the idea. Just like 6 is between those two values, 1 is between those two values. Everybody see that? Okay, so take out your worksheet, your homework stuff. Okay, and if you look at this intermediate value theorem piece right here, okay, I asked you to do problems A, B, C, D, right?
Yeah.
After that, all I want you to do is problems 3A and 3B. That's it. We have more to do, but I'm going to give you about 5 minutes to quick look at some of the pieces with intermediate value theorem. So all I'm asking you to do, just 6 problems. Okay, that's going to be all we need. We'll come back to it later on, but go ahead and get your feet wet with that, and then we'll move on to our more important piece for the day. Okay, I'll come around and check in with you.
I prefer my feet are dry.
Okay.
Hannah, do you like having wet socks?
No. That is disgusting.
A, B, C, D. And on the back side, just A and B. So A and B are just like what we just did. Test each of those points. 1 should be smaller than 11. 1 should be bigger than 11. And you'll substitute 1 should be equal to 11. That's all. Okay, why don't you try that first? What you doing? Okay. Hold in 1 and 2. Hold in 1. Come up with an output. Hold in 2. And 1 should be negative, and 1 should be positive. That means you're going to 0. Good. What you doing? So here you come out with, let's see, so -1 and 3, that's going to be 2.
Yeah.
So
So it'd just be +2, so it'd just be 2 and 1/16.
yeah, so 2 and 1/16.
And
So the idea is that because you have 1 that's positive, because you have 1 that's negative, somewhere it must cross over 0 in between that.
so for
IVT guarantees there's a 0 somewhere. Yep. 2 more minutes. Yeah, so, yep, good. IVT guarantees 0. Good, that's just fine. Yep, that's fine. Yes, that's what you want to write. Yep. So Aiden asked a good question about just kind of the statement that we make. The IVT guarantees a 0, that type of piece. I'm trying to prepare you in that as we prepare for the AP exam eventually. You need to be able to justify your reasons for making a statement. So some people will say, must there be a 0? And just answering yes does not work. You must say yes, the IVT. You don't have to write intermediate value theorem, you just write IVT, the IVT guarantees it. And the fact that you invoke the intermediate value theorem I'll give you a point. How many AP exams will we have this year?
I don't know. 1.
Just you.
3? Just 1 for you? Corey?
2.
You guys have
He's
a-
just COS.
2?
Thank God.
Mr. Hartman? 2,
No, he's just, yeah.
1,
No.
1,
No,
3,
he's just-
3, 3, 2, 2, 3, 3, 3,
I don't have this.
1,
Oh, shoot.
2. So AP Bio and AP Psych,
Oh.
Oh, shoot.
AP Language Comp. Okay. So AP Psych, AP Language Comp, AP Macro, AP Bio, AP Calc. Those are some of yours.
How did your class like on average do like last year?
4. Year before they did great. As 100% correlation, I mean, it's tough because it's 100% correlation to how much you try. But when I come to class and people have missed 8 days because of golf and they walk in and they complain because like, well, I don't have to do anything, right? Because I haven't been here. I mean, how are we supposed to prepare for the AP exam then at that point? Which, with all due respect, I think golf is a great sport, but when people are not spending time in class to prepare, so I've adjusted the way that we'll prepare this year, and hopefully I'll go okay. But you do not have to pass the AP exam to get credit for this course at all. But if you want to do well, it is 100% about the effort that you put in. Harder the classes work, the better they do. There's
Do
no
you
doubt.
have to write IVT guarantees a 0 for these?
Nope.
No.
Nope.
Okay.
What's our like showing like what's our answer thing?
For these two,
Yes, sir.
just finding your C value.
So what do you write for your statement?
You don't have to write a statement for those two. For the first ones, you do. For the first 4, you do. Okay, last question, we move into the rest of the notes. Yes. Yep, that's fine. You got it. Okay. All right. Love this lesson. This is the beginning of us. We kind of almost get to say goodbye to limits for a little while, okay? And we move on to something different, but we get to connect limits with the bigger idea. If you remember when we started this course, we said that there was a big question we like to ask in calculus, and that's if we have a curve, we want to know the slope of the tangent line, right? And so we're going to put it together, and we're going to use definition 1. We call this definition 1. Given a function, f, a little drawing here, we piece it all together. I love the drawings. In calculus, the drawings really aren't that complicated. They make so much sense in terms of just understanding the calculus. Is amazing. It took people that long to formalize it. It took many, many years. But I have a point A at which I would like to know the slope of a tangent line. See if you can help me come up with a couple of these pieces. If that is A, does anybody know what this is? Good, I like that idea of L. Yeah, we could write L, but I'm not going to write it. What would I do to come up with L? How would I come up with L? I would take A and do what with it? Plug it into the function, right? Yeah, good. So we're going to write f of A, which would be the same thing as L. Good. Okay. And then we know that we struggle to find the slope of a tangent line. So instead of, 1 point, we're going to create a second point, right? And that second point, I'm going to move out here. I'm going to call it X. So what should we call the Y value? F of X. In order to find slope, we just do y sub 2 minus y sub 1 over x sub 2 minus x sub 1, correct? So I have the following statement. F of x minus f of a over x minus a. That slope would approximate the slope of the tangent line. If you wanted to come up with an exact value, what would you do with x? What have we talked about? You would move x closer to a, right? That whole idea of moving x closer to a, that's what we've done. A way of writing we move x closer to a is to simply do this. Slap a limit on the front. Let x go to a. So you've tied together slope of a tangent line and limits into one piece. This is how we determine slope. This is definition number 1. there's another definition that we're going to use, which is more of a formal definition, but that's beautiful for us, and we're going to make use of it on this test. You guys will be able to practice it. You're going to do a great job with it. It's a lot of algebra, and you happen to be really good at it. So find an equation for a line tangent to the given function using definition 1. Okay, that's what we're going to practice right now. So what I do is this. I have the limit as x approaches a of f of x minus f of a all over x minus a. Okay? Limit as x goes to, what is the a value in this case? 1. Of f of x, what is f of x? X squared minus 3. Minus, what is f of a? What do you get if you plug in 1? You get a negative 2, don't you? So it'll be a plus 2 on the end. Divided by x minus 1. So all we do is we set up a problem similar to what you've seen. Now we will reduce it. Using the methods that we've talked about. We have x squared minus 3 plus 2 is x squared minus 1 over x minus 1. Have we been able to determine those limits before? And so we get a chance to do it again. Limit as x goes to 1 of x plus 1 times x minus 1 over x minus 1. Notice how the x minus 1's reduce, and so your limit is 2. It says find an equation for the line tangent in order to save on time. Is everybody okay with saying that if m is equal to 2 and the point is 1, negative 2, that you would be able to write your equation using y minus y1 is equal to m times x minus x1? Do you want me to carry that out, or can we say you can do that? You're okay with that? You can write your equation for your lines. We practice that plenty. Let's look at some other examples then. Okay, this one, I have my function 3x cubed minus 1. What makes this one different from the previous one? Yeah, I've got a cube. Cube, how is it going to factor? I don't know. Let's try. I have the limit as x approaches what? 2 of 3x cubed minus 1 minus what? 23 over x minus 2. That's the limit I would like to determine. We should be excellent at our algebraic approaches to finding limits. Limit as x goes to 2 of 3x cubed minus 24 over x minus 2. What would you like to do now? Factor out the 3, okay. Limit as x approaches 2 of 3 times x cubed minus 8 over x minus 2. Now what? Factor the cubes? I don't remember how to factor cubes. What if I don't remember how to factor the cubes? So if you know how to factor a cube, go ahead and set up like that. If you don't know how to factor the cubes, I'm going to set up the synthetic division. I put the solution of 2 there. I've got 1, 0, 0, and a negative 8. So I drop the 1. I've got 2, 2, 4, 4, 8, 0. So if you forget how to factor cubes, you've got this right for you. Limit as x goes to 2 of 3 times x minus 2 times x squared plus 4x, 2x, plus 4 over x minus 2. Notice how those reduce. What do I do at this point? Just plug in 2. 2 squared is 4, plus 4 is 8, plus 4 is 12, times 3 is 36. We've determined the slope. As you can see within our work, we've worked with two very kind of nice behaving polynomials. We have an x squared, we have an x cubed. We won't be dealing with, say, sine of x or natural log of x or something like that, but we do want to venture out a little bit. We're going to skip letters A and B, and we're going to move to ones that are just slightly more involved. You want to be able to learn how to work with a square root function, and you want to be able to, hey, don't do that. Why did it do that? Oh, there. Oh, wow. Okay. I know that probably looks dumb. Like don't I know that I could grab it and it would move? I just feel like I must have grabbed it with my thumb and my finger. The boards are so sensitive that you don't actually have to touch them. They can sense your heat from like a 1/16 of an inch away. You don't actually have to touch them. So if another part of your body gets too close, it'll change. So we want to be able to learn how to deal with this type of problem and this type of problem, namely a radical function and a rational function. Again, we're not going to do with exponentials. We're not going to do with trigonometric. There's not an algebraic way of really working through those. But we can algebraically work through these. And you guys can too, because you're really, really intelligent. You guys realize that by like making this class, you've like said you are a great student at this point? Like you realize your college really doesn't care if you get an A in calculus or not. You've made it. Like you are getting into college. You are going to get scholarships to go to college. They are happy with you, right? Yeah. So take some stress off your life. You've made it. You know what I mean? Does that feel good? You're actually starting. You're in college, right? This is like your freshman year. Most of you are going to go off. You're going to be like starting your sophomore year, aren't you? Yeah. Way to go. You're ahead of the game. You're super successful. Get a job, pay taxes, so I have Social Security. Here we go. Limit as x goes to what? 6. Good. You've got that. Of what? Of x minus 2. Minus 2 all over x minus 6. Now, if these look familiar, it's because we practiced these type of limits before, haven't we? And we practiced them to prepare you for this moment so that you know what to do. Anybody state what I do in this situation to simplify this limit?
Like the compound.
Spanish, we do Spanish. Multiply by the conjugate. Thank you. So I've got the conjugate.
Yeah.
Square root of x minus 2 plus 2. So the problem you're doing right now, I've seen an example problem on an AP exam like this. Just the challenge is that once May comes around, a lot of times people don't remember this piece or their algebra gets a little sloppy. So that's what makes it a little bit challenging. So we have the limit as x goes to 6 of what? X minus 2 minus 4 over the quantity x minus 6 times that business over there, which is the square root of x minus 2 plus 2. Oh boy, it's Christmas, isn't it? What happens? What is this right here? That's x minus 6, isn't it? So these reduce to 1, leaving me with a 1 in the numerator. And so I have the limit as x goes to 6 of 1 over the square root of x minus 2 plus 2. Notice what we've talked about. From the beginning, this limit, this is a discontinuous function, isn't it? It's discontinuous at what value? At 6. What did we do? We removed the 6, which was the discontinuity. We removed the discontinuity, and then we fill the discontinuity by plugging in 6, and we get 1 over 4. So the slope of a tangent line always ends up being that filling of the discontinuity. It always ends up being this thing that we've talked about so much. Does that limit exist? Yeah. Yes. Now what we're doing is we're filling in the bubble. And that ends up being the slope of a tangent line in every situation. It looks so simple, but because it had an open circle, it created such a challenging factor for people for so many years, and now we formalized it in a way to make sense. That is what we're doing from a graphical viewpoint. Last one. I've got 1 over x minus 1. I've got 3 and 1/2. Oh boy. Let's try it. Limit as x goes to 3 of 1 over x minus 1 minus 1/2 all over x minus 3. Okay, complex fraction. What are we going to do? Common denominator, so I'll multiply the top and bottom by 2 and top and bottom by x minus 1. Here's where you get sloppy. Stop being sloppy. Take care of those negatives in the subtraction. They come up all the time in calculus. Be aware of your negatives. I have 2 and then what? Minus x plus 1, because you're distributing the negative all the way through, over 2 times x minus 1, all over x minus 3 over 1. Beautiful. I may not see what's going to cancel right away, but I am going to show patience in this situation. Patience is a virtue. And at the top, I have the limit as x goes to 3 of 3 minus x over 2 times x minus 1, all over x minus 3 over 1. What now? You could factor out the negative. As I multiply by the reciprocal, I'm going to take Addie's advice and see that the top and bottom are different by a factor of -1. So if I just do that, my shorthand way of them being able to reduce those. I have the limit as x goes to 3 of -1 over 2 times x minus 1. There we have it. Now we can plug in our 3, and we get a -1/4. We've removed the discontinuity, and then we filled the discontinuity. The value is -1/4. You've learned how to deal with the polynomials, you've learned how to deal with the root functions, and you've learned how to deal with the rational functions. Those are the 3 type of functions that you want to be able to deal with. So, opened up to the last part of your homework.
Oh, wait, never mind. I see what I did.
I just had 8 questions for you on this page. They are all algebra intensive. You can see that some of them are polynomials, and some of them are rational functions, and some are radicals. Notice how I tell you what A is. So I give you that first x value, okay? Say that x value is -2. I don't give you the y value. How do you find that? Just plug in the -2 to find that value, okay? So you've got about 10, 12 minutes right now. You're going to have all day tomorrow to work, which is a Friday. And then Monday, hopefully you can come in and kind of have, define what are your questions on your study guide and what are your questions on your homework, okay?
Did we get our study guide?
I think you were maybe out and did I put one on your desk? Here you go. It should be ready. The study guide looks bulky. Just understand that first page should take you about, I would say, a minute and a half. There's a lot of space to write with the graphs that you're given, so it's not that bulky of a study guide. So I'll post the answer keys as of late, and I will come around and answer questions. Part of me thought last night about pushing this test to Wednesday. Does anybody know why I don't want to do that?
Because it puts everything else back.
Because coronation's on Wednesday. Next week, is it not?
It's on Thursday.
I didn't know we did that anymore.
Yeah.
Who knew we all did
It's
that?
Wednesday, isn't it?
It's
Yeah.
Hannah's solo day, by the way.
So I'm just saying that Wednesday all of a sudden is a shorter day. It's homecoming week. If things could get kind of drawn out. I think we could be ready for this test, especially since we have the weekend. We have a work day on Friday, work day on Monday. I think we could get ready for Tuesday. Okay?
It'll be
Yes.
totally straight to these.
Nope. Nope.
Just wait.
There you go.
Wait,
Does that feel
do we
good?
have to do these or these?
Nope. Absolutely not.
Wait, which ones do we gotta do? It's all the
4, 5, 6, and 2.
Or wait.
2.5.
Are we doing 2? Number 2? And are we doing number 2, A, B, C, and D?
No.
Is this up there? And then for 3 are we?
Oh,
No, I just
probably
copied it.
not.
I was like, none of these look right. C and D.
I don't know. How about 4?
Are we doing 4, 5, 6?
At this point, I should just rip out those pages.
Hannah, are we doing 4, 5, 6?
I'm sure. We don't do you aren't ready?
Hannah, 4, 5, 6?
Not that one. Not these ones.
None of that
Huh?
page.
This one.
None
I was
of
on the
this
wrong
page.
page. Yeah, none of that page. None of that.
Okay,
And
none
none
of
of
this? Hannah. C, D,
Is there
and
anything else?
4?
You can look at Jordan's. I don't, are we supposed to do these two?
Mr. Gensler, we should do C and D of number 3.
No, you don't need to do C and D of number 3. You only need to do that first 4 on that one, and then those other 2. That's all you need to do on that section. That's it.
Okay.
If this was a year where we started school after Labor Day and we had 45 days in a quarter, then we would do it. But because we choose to start when we start, our days are reduced first semester by about 10 days. So all the people I teach with that teach for other schools, they all ask, how do you cover all your material for college algebra? That's one semester course. Like I can carry this over in second semester, right? But college algebra, it's packed. It's packed. Michaela Bass, it's her birthday today.
Fast.
Boss, whatever.
I knew it was someone's birthday and I couldn't figure out what it was.
It's the same as the actual.
Thank you.
Is this one up now? I did not write.
So don't worry about that. That's how I used to write. Just make a statement about the intermediate value theorem.
Mr. Gens, I have
Okay.
some more questions.
Let's take the birthday one and I'll put it underneath the schedule. I need to buy more clips, don't I?
Yes.
There you go.
I didn't take it.
Yes.
Well, you can have it.
So for this one, you told me that I need to cross multiply, so for this one, I cross multiply.
Yep, but I said you don't have to do 6 with the challenge.
Oh.
Yep. You don't have to do 6 with the challenge.
Okay.
Okay? You okay?
Yes.
Yes.
Can we get a microphone? Storm and sun.
Yep. Use your
That was a
graph.
one day thing and we missed it, so it's never happened.
today.
No.
So,
You're in a class.
yeah, so I look
I
at
think
the
my son
alphabet.
ready for
I'm
this
gonna
day.
talk to student council and see if you can sing for the
Less
coordination.
epsilon.
Why would in the
X
world
minus
would you do that?
A less than delta.
Well, Hannah, you
So
will be a
part of this
homecoming
problem is to
queen,
see,
so
can
we'll
you
not.
write it in this
I
form?
will not.
If as
We can
x
do a
goes to
homecoming
5
I will be.
of the function
Can you
is
decline?
equal to 0.5 minus
I don't think so.
I hope
0.5
so.
So what we did is we went up 0.1 to 0.6, and we went down 0.1 to 0.4. To find the x values, we just inverse.
Yeah.
That's what I did. He
says
that.
Be pretty bad at it.
Because these kids, that's what they don't
You have to
do.
literally just not know what it is or the concept.
Let me know when you. Yeah.
Unless you just pick it up.
I hate grape juice.
You got your short is.
Mr. Gens, are you an apple juice or an orange juice kind of guy?
There's only one correct answer.
Yes, there is.
There is.
But I don't know if we have the same.
I don't know. We'll wait for him to
It's
answer.
better.
He's not gonna answer. What's the right answer, Lily?
I'm
Can't
sorry.
be biased.
I made a mistake because I did the same class as everybody.
I hope.
Point.
Oh,
Thank you. You are so correct about
that's the
that.
one. Wait, let me.
What about apple juice and orange juice combined?
I like how all
That's
these are
weird.
weird. That's really weird. Lily, which is
Six,
correct?
four,
I've never
three,
tried it, but like
and point
vegetable.
411.
Aaron's on the
Wait,
wrong
writing a-
side.
Oh,
You like
no, wait,
orange
you have to write a.
Yeah.
So these two values are.
I like
Yeah, I know, I saw
grape
that.
juice.
I wrote that, like, I like that wrong.
So here's the mistake.
Taylor.
No, like, why am I?
Know that that's one.
Taylor doesn't
Why
like
one?
it.
Because I'm
Oh,
actually.
that's-
Oh,
We're wrong.
That's
They're just all wrong. No.
Okay.
Are you a straight
Here,
changer?
put 5 or
Okay.
6.
What about you?
So how'd you?
Okay.
Oh, wait.
So we were at
Gallons of it.
So
Negative 2
we're
over 2 is
comparing
negative 1.
Probably what this You're probably exactly what.
Aaron! Aaron did the big jump. Drink 45 minutes in one day.
So we did 5 divided by 6.
That's a lot.
I always shit myself after.
Oh, wait, never mind. I think.
Not gonna lie.
Yeah.
This should be like pineapple.
Is that what I did wrong?
So we're gonna see
Yes, it
how
is.
far
Yes,
these
it
are.
Yes, that's probably it.
Yes, it is.
You're entitled to be wrong, Lily, it's okay.
So we're gonna take 643 and subtract 0.5.
Oh, that's interesting. That is very interesting.
That's
an opinion.
It makes sense.
And then I'll take 0.5
Someone did that.
times 0.11.
And then you tried it.
They never picked it up, so maybe that's
Two.
right.
And I did small.
You know?
So I'll bring that up in class because that.
And I was like, you know what?
Yep.
Let's just go.
You can see why I
So I was like, yo, whatever.
Because it's between.
So you ordered it.
That's what happened in my mind.
Jake's or?
We're gonna help.
I did it.
Matthew.
Because I made it.
Oh.
And I was like, and then they never came and picked it up. Well,
That's
actually,
pineapple on an Alfredo sauce.
no.
So.
I'll bring it up.
You got FX is that.
Bacon.
Minus.
And pineapple. I think I do the Nelson's sauce.
That's like the opposite.
The opposite.
Yeah, it's so true.
So like, that's what I would mix with cement.
I got 3 extra. You're right, that's fine.
I know, but I was out there, I was in Lake City, we were talking about Red Wings,
That's not you.
and we were saying that, I know my dad, best friend was football. So we went to a restaurant after, so I just told her.
Sure.
Yes.
And I was like, can you like explain these three
Yeah, the trust is-
crust? And everyone was a little like I was.
I think that this is the best way
Wait,
to
did we get out of
talk
Because you're-
Okay, so now I'm
So the
gonna
first
type
is, if you plug in the X value, do you get an output? And right here, if you plug in 4, there's no output. So this one, so 4 fails at number 1.
Hannah, what are you doing
Okay.
tonight?
Then we
Me?
move over
Yes.
to
I
1.
work.
If I
What time
plug
do you
in
get
1, do I get an output? The answer is yes, it exists. So
Can I-
30.
it works for
I'm done at
number
7:30,
1.
I'll be home at 8.
Then we check number 2, okay?
Okay, can
Number
I
2,
call you at
I
like
look at the limit from the
8:30?
left,
Sure.
I look at the limit from the right.
one more.
Limit from the left is -3.
I like called you yesterday, but I think you were working.
Those are not the same.
Hannah, were you working
So
yesterday?
I was
fails
working, I
because of
apologize.
the-
Okay,
This
well, I
one passes
apologize.
number 1.
I just don't want you to like get through the whole thing. and-
This one, if I plug in -5, I get an output of 3.
Ours was
So
6:07.
passes number 1.
I would love that.
Yeah.
Limit is 7. Limit is
What
7.
about these two?
So the limit
Because
exists.
you took it.
Passes number 1, passes number
You
2.
saw something.
Number 3 has to be that the output is the same.
You
The
started bleeding.
output is 3, but the limit is 7.
Square root
So it fails.
3
I
minus,
know.
uh-oh.
Yeah. It's a minus. Oh, no, no,
Don't
no,
get
no,
the
no.
account.
Because
They can be done by Monday.
I know you're types.
Still a minus.
Oh, it's
You're
a
asking
big
what different.
thing. Background thing.
I'm literally carrying
I did that.
Those are the 3 situations. No point, point, no limit. Point, limit, but not the same.
Eric Circus, brother,
That's the same.
We do all of the continuity.
I
No.
don't know, actually.
Not all of it.
So, once again, you guys, your continuity worksheet, you don't need to do most of that worksheet. You just do those first four, A, B, C, D.
That's it.
Oh, I'm sorry, the continuity, yes, continuity, sorry. Intermediate value term, I'm sorry, that's what I was thinking. Sorry about that, sorry. Yep.
Is it zero?
Right? Just do
Don't
those.
you plug in the negatives at first?
Nope, nope, Yep,
Got
don't
it.
do those.
Yes, you're an apple juice or an orange juice kind of guy.
Orange juice.
Leave. In the morning?
Apple juice in the afternoon.
Who drinks any kind of juice in the afternoon?
I do.
I do.
I don't. That's weird.
Right now, I am no
drink-
juice, I am
For supper.
drink packets with 1 gram of sugar from stevia. That is where I live.
Do you still do the one round in my
I know you
Well,
like
I'll do
it.
on the weekend, and I can't wait for it.
Maybe that's where.
I will admit that over the past 5 months, it's turning more like 2 Mountain Dews on the weekend.
Can you have like a zero?
So the artificial sweeteners actually impact you just as bad. So when I had a drink packet, there's just 1 gram of sugar, and it's from a natural flavor source, the stevia plant. So that's supposed to be safe for me, but the others, they say no. So, whatever. I get my blood check this next Tuesday to see how bad my blood is.
Maybe you should like down a bunch of Mountain Dew before you go.
I'm like, no, it checks my numbers over the past 3 months.
Are you gonna be here tomorrow?
Yes.
Okay.
So it's a 3-month kind of test, so. Yeah. You guys have a great day. I will. We are ready to go. Good luck tonight, Aaron.
Thanks, guys.
Yes, swim like a good fishy.
I'll try.
Swim like a fishy. Maggie, quiet in class today.
Oh, God.
Do your homework? Sure. I did all of it. Right, Ryan? Did you say right? No. I did right to us losing Connor.
Girl, thank you.
You saw what she put me in though.
Hey, yeah, Aaron.
Oh, I miss.
That's 220.
Oh, yeah. I forgot how good rice cookies are.
How do you forget that? You know you
Wait, you're smushed? What will I not?
what's the theme to volleyball tonight?
USA.
Oh, okay.
Are you gonna be there?
Beaker and I are wearing shiesties.
You're for real gonna be there?
I think so.
I didn't know that you were coming.
We're wearing shiesties.
Are you like going with, like, are you going to be able to? You just have to. You just let
Oh, dude, that's so funny. Shut up. You silly goose. No, I don't know. I don't think so. She didn't even go to Austin school. She goes to Grand Meadow School.
Then why would you tell me your school?
She was she went to Austin and then there's like way too much fighting in school. So yeah, so she went to Grand Meadow. She was in Lansing, which is like between Austin and Grand Meadow. It's like living in Clark. It's like living in Clarksville. Neither was Lansing. So she just.
So where did you live in Austin?
So here's Austin. Here's Lansing.
It's like living in Clarksville, but going to Riverhead.
So this is Austin. This is Lansing.
Change clothes and then like I take my time for class. Like a response. I'd rather not.
She has like 4 people. I think there's 100 people that yeah.
Oh, for real? 100?
1 billion people.
Guys, I'm crying.
It's so funny.
What, powder puff?
Yes.
It started with Ava said the TikTok because everyone just gets on the TikTok is so funny.
How we doing?
I didn't watch the TikTok.
Good.
Some for good.
Cool.
It wasn't, it actually wasn't.
I'm beginning to wonder if you're the accident-prone one after the falling incident.
So it was
Yes.
Okay, got it. What's the thing that's stressing us in life right now? What's stressing you? Okay, homecoming.
Powder puff.
Powder puff.
Math.
Tennis.
My father.
Math. Okay, that's okay.
Well, a little bit.
That's all right. Hey, it's all right. Kevin Jens is stressing you. It's all right. So stress is good because it actually helps us to perform better. But too much stress is a bad thing, then, right? Too much stress is a bad thing. So we got to handle our elements of stress to some degree. Something I want to kind of give you guys just a 2 cents of advice about is this. My guess is that as you guys go throughout your day and your week, do you sometimes make predetermining judgments about how the day is going to go?
Yes.
Like, for example, do you ever say, oh, we got that game coming up? That's what happened last year, so this year it'll probably end up like this. You ever walk in that class and say, that's what happened last week, so it'll probably be the same way when I go this time. Or last time I talked to that person, here's how it went, so it's going to go this way again. Because we like to develop and make predictions, don't we? We are people of habit and nature. We like to make predictions. I got news for you. Whatever you got going on this afternoon, it has not been determined yet, has it?
No.
No. So that soccer game, it might not be 1-3. It might be 6-1 on your favor. That cross-country meet, it might go your way. That volleyball match, it might go your way. That conversation that you don't want to have, it might be a great conversation. Who knows what?
What about tennis and diving?
Tennis and diving.
Yeah.
Tennis, it might be 7-0, baby.
What about swimming?
Diving might be perfect 10s. Swimming, we might be breaking pool records. Who knows?
Okay, I don't know about that one, but we might win.
I will tell you this much, okay? Rockets don't know how to swim. And second of all, so this is an important element. And how about this? If I teach it to my kids, is it important to me?
Sure.
You're darn right. So my daughter heads off to college. She's got a roommate on the cross-country team. She finds out she's not in a room with just her and her roommate. She gets paired with a third roommate, okay, from a different country, who's a senior, who reaches out to them and says, and I quote, I hope this year goes well, because the last 3 years I've had horrible roommates. Now, at some point, we got to look in the mirror and say, for 3 years we've had some horrible roommates. The problem may not be the roommates. The problem might be me, right? So all of a sudden, I'm saying, Kira, are you excited for school? She's like, yeah, I'm excited for everything except for the whole roommate thing. I'm like, oh, I got you. She's like, yeah, I'm just worried about that. I said, well, you don't know how it's going to go.
Where's she going to school again?
Lacrosse. I said, you have no idea how it's going to go. I said, it might be possible that her 3 sets of roommates she had before it were totally crappy roommates. I said, it might just be that you have a way of working with it. So all of a sudden they get there, they're all nervous, and I said, after all the parents leave, I said, the 3 of you, go get ice cream or something, sit down and say, hey, what do we got to do to make this work? I called her the other day, I said, how's roommate's thing? She said, it's great. She's like, I was totally worried about it, and there was no need to worry about it. It ended up just fine. Okay? So be careful about making those predetermining factors. The way you approach it sometimes affects the way it turns out. So if you see hope and opportunity is what it can be, without a doubt, which is why we need it. Because our Vikings are not favored to win tonight. Okay? So who knows? They might. I'm hoping for the best. But keep your day, opportunity ahead of you. Take all your notes. We're going to do an easy lesson today. How about easy?
Yeah.
Easy? Let's do easy. Everything we do today, you already know how to do. Not only do you know how to do it, you are exceptional at what we're doing. You've just forgotten some of it.
Oh, word problem.
Just tell us the formula and we'll do this.
We are actually skipping all the way forward to 1.10 because I have to leave early next hour. Okay? And so I need a lesson that I can teach within 20 minutes. So you're gonna flip to 1.10, we're gonna talk about lines. Can't get any better than lines, get it? Let's go. Just about all the way to the end, 1.10, okay? 1.10. We have some equations for lines. I'm going to record this hour so I can get out of here next hour. Screen capture, ready, set, and... See, this is what it did to me the other day, too. I can't, but that just takes a picture. I don't want to take a picture. I want to record. I tried that.
Try the X and do it again.
Yeah, I tried that too, and it didn't work.
Where's the thing like on the smart board where you like tap the corners?
Yeah.
Recalibrate.
Yeah, it.
Did you try your finger? Tap around the area.
Oh well, forget it. We ain't recording, I guess. So if you're not here, go ask Lily after a tennis match. Here we go. Lines, slope formula. M is equal to, see what you remember. This is all kind of a quick review from things we've learned before. What is this formula for slope? Close? That's slope-intercept form. Y equals mx plus b. That's slope-intercept form because m is your slope and b is your y-intercept. What's our formula for slope?
Y squared minus y.
Not y squared, but y sub 2 minus y sub 1
That's what I meant.
over x sub 2 minus x sub 1. That's our slope formula. Given our slope formula, we can come up with our point slope form, which is y minus y1 is equal to? Excellent. Paige has got it. Those three formulas are very important to us as we work through our kind of characteristics and properties of lines. Now, I like to kind of organize my thoughts regarding lines using this piece right here, okay? And that graphic can help me understand slope, namely that if the line goes like that, it's referred to as a positive slope. Moving from the left to the right, you can see we're going up. Whereas the other part, we have negative slope. We're headed down. Anybody know the next slope? Neutral. That's what they said the other hour, too. I like that. Neutral, yeah. Positive, negative, neutral. You guys must come out of chemistry class or something, huh? Yeah? Well, what's between positive and negative? Zero. Yeah, exactly, yeah. That's zero slope, okay? And then what if it's straight up and down?
One.
Undefined. Some people say it's infinity. Well, maybe it's negative infinity. Those are very different from each other. So we go to undefined. Now, the other piece I want to talk to you about is this is a horizontal line, and it has an equation of y equals. Whereas a vertical line has an equation of x equals. So we're going to get to the x equals and the y equals later on in today's lesson, but that's something to keep in mind, okay? Last two pieces before we begin practicing some problems is parallel and perpendicular. What is true about lines that are parallel? They never cross. Good. What else is true about their equations?
Same slope.
They have the exact same slope. So in that situation, you know those lines are parallel because their slope is the same. What is true about lines' slopes that are perpendicular? Close? Opposite and reciprocal. Opposite and reciprocal. Okay?
Why is it 12?
I just made something up. No matter what the y-intercept is, the slope is what determines that they are, in fact, perpendicular. Okay? All right. So I'm going to go down here, and we're just going to practice first by finding slope. I find the slope by doing y sub 2 minus y sub 1 divided by x sub 2 minus x of 1. And I get 8 over negative 2, which is, if you were to write negative 4 over 1, that's fine. If you were to write negative 4, that's fine. If you write negative 4x, that is not fine. X is not part of the slope. The slope is a number. It is a real number. So not 4x, okay? Go ahead, do B, C, and D. See if you can come up with the slope in those situations. Go.